Hi everyone, this is going to be a tutorial video on Avogadro software, how to use it, how to draw molecules using Avogadro. So before going to the details of constructing molecules using Avogadro, so let's first give a little bit introduction about Avogadro and how to get Avogadro for any system like for Windows, Mac or Linux. So to do that, you just have to type Avogadro in your browser, and yeah, after doing this, you'll get something like this and you just have to click on that. So after clicking on that, you'll get several menus or several options that are available at the top. So including this download option, there is a manual, there is a discuss. So it's a kind of forum where you could get a chance to discuss the issues related to Avogadro, and there are other things as well. And as you go down in this page, so yeah, so you'll know a little bit more about Avogadro. As you can see, so this is a molecular builder or molecular editor software, and which is available for Windows, Linux, and Mac. And the very important thing about Avogadro is that this is free and open source, and it's comparatively easy to use. Like to get Avogadro installed on your system, so you just have to click on this the download option, and so then this Avogadro will get downloaded automatically. And so after that, you just have to do the installation, which I'm not going to do because I have Avogadro previously installed on my system. So I'll directly open Avogadro, and will do the tutorial for drawing a molecule using Avogadro. So now you can see my screen. This is how Avogadro looks like. So there are several menus that are available on the top. There are also tools. These are different tools that will be helpful in drawing drawing molecules. And there are also another set of options that are available on the extreme left of my screen. So yeah, so before drawing any molecule, I would like to give a brief introduction about these things, where they actually they are useful. So there's menus, the different menus. So there is one view menu. So this view menu is when you click on that, so you could see there are different options. So you can see one with this set background color. So this view menu is like helps to customize the view of molecule as well as its background. So in this background color, so you could set your background color whatever you want. So right now so in my case it's black. The next one is the build menu. So this basically this build menu has also several advantages. So one of which is again, so I'm only discussing the important one, which one has to know in order to construct molecules in Avogadro. So there is one which is insert. So this insert has options like DNA, RNA, fragments, files, and peptides. From this insert menu, you can directly insert the DNA, RNA. I mean, some large molecules and fragments like benzenes. So there are some inbuilt fragments that are available, and you could use these directly without constructing them, because those, like constructing those molecules and optimizing them are in as a tedious process. Okay, the next menu is here is the select. So using the select menu, you could choose or you could select your atom, your bond, any portion, any residue, whatever you want. You could do that using this select option. And there are also extensions which I'm not going to not going to discuss right now. There is crystallography, so you could construct unit cell using Avogadro under the settings and helps. So below that there are different tools. So yeah, apparently there are 9 tools, but out of which we're gonna be using only 4, because those 4 which I'm going to discuss, so those are like basic tools, and mostly you will see like these 4 tools are important to construct a molecule and whatever like navigations we want. to control our molecules, so we could do using these four tools. So these four tools include, so first this draw tool. So this draw tool will help in drawing the molecule. Then there is navigation tool. So using this navigation tool, so one would be able to drag the molecule from one position to other, or rotate the molecule about one axis or two axis or three axis simultaneously. So then the third one we don't need much, then we could move directly into this one. So this one is basically the geometry optimization tool. So using this tool, we could optimize the geometry of the molecule. So this geometry optimization is Avogadro, is based on classical force field optimization. Yeah, so the next one is the measuring tool. So the measuring tool measures the distance between two atoms, and when in a diatomic molecule, and when a third atom adds to the system, so it also measures the angle, also as well as the dihedral angle. So this measuring tool measures the mainly the distance, angle, and the dihedral angle. Okay. Next is the there are set of options that are available in the extreme right, extreme left of the screen. So these include the model. So the model we're going to use for the molecule to construct. So here, so this is a ball and stick model. There are also other options. So for example, hydrogen bond, their level. So hydrogen bond will help in visualizing the hydrogen bond that are available in our molecule. And label, so label will help in labeling different atoms in a molecule. So each of these options have some setting at the right of them. So using these settings, one could edit those options, or one could customize things accordingly. For example, if you go to the setting of this ball and stick model, so you could see there are different options like atomic radius. So where using this you could control the atomic radius of the atoms in a molecule. Also there is a bond radius, so which you can also increase or decrease. There's opacity, so you could play with those things. So these things one could play later, but the basic things which one just like one would definitely know in order to construct a molecule. So these are for these four tools, and there are few options out of these. So now let's get started with constructing a molecule. So we'll start with this draw tool. So let's start with some simple molecule. So when you click on the draw tool, so one additional set of options will start popping up at the bottom portion of the left side of the screen. So where you can see there are two drop down menu. One is the element and other one is for bond order. So using this element drop down menu, so we could select whatever atom you want. So there are few selected atoms there previously. Also there is one other option. So using these other options, one could select any atom from the periodic table. Then there is another drop down menu, so which is basically the bond order. So using this you could be able to select the bond order, whether single bond, double bond, or triple bond. Now let's start with constructing molecule. So we are going to be construct hydrogen molecule, so the simplest diatomic molecule. And to start with, also diatomic is a good example. Yeah, let's select hydrogen atom. So after selecting this hydrogen atom, just click on the screen. So now this hydrogen atom starts appearing on the screen. The next thing is to make a is to add another hydrogen atom and to make a bond between these two. So to do that, so we have already selected this bond order, which is single. So simply you could draw from this hydrogen atom. Just just hold on your left mouse button and drag like this. So automatically the second hydrogen will start appearing, and this is a hydrogen molecule. And this hydrogen molecule is not optimized. Now, to do the optimizations, you just have to use the optimization tool. But before going to the optimization tool, let's play with these molecules a little bit using this navigation tool. So what this navigation tool does, so this navigation tool, so using this navigation tool, you could shift the molecule from one position to another. So this could be done using by holding on the right side of the mouse and dragging from one position to another. Also, you could rotate that, so which could be done using the left button. A rotation can be done by holding in the left mouse button and using the cursor. So in which direction you want to rotate your molecule, about which axis you want to rotate your molecule, whether it's about it's around x axis, around y axis, or whatever. Okay. Yeah. Then we'll move into this optimization tool, but before going to the optimization tool, I just want to measure the distance between the two hydrogen atom. To measure the distance, so you have to use the distance the, the measuring tool, and after clicking on the measuring tool, one has to click on the atom. So first clicking on this hydrogen atom will label it as 1, and then clicking on the second will label that the second. So when one clicks on two different atoms, so the Avogadro automatically measures the distance between two atoms. So when we add the third atoms and click on that, so it will measure the distance as well as the angle. Now you can see the distance between these two hydrogen atoms is 1.6 angstrom, so which is not the optimized geometry of hydrogen molecule. Then you have to optimize the geometry, so which is basically using this optimization tool. In this optimization tool, there are also couple of drop down menus, so which is force field. One has to choose a force field, so which is here this UFF, which is universal force field, and there are steps for update. Just keep this whatever it has and start the optimization. So as soon as you start the optimization, you would notice the decrease in this bond length, and now stop the optimization. Now measure the bond length again between these two hydrogen atoms in a hydrogen molecule, and that got reduced to zero point 0.7 angstrom. Is the result of this optimization, result of this geometry optimization. Now I assume all the viewers are aware of constructing a simple molecule, measuring different parameters, and optimizing the geometry, rotating and dragging the molecule. So all of these things. So next we'll do or we'll construct we'll add an extra complexity to construct a triatomic molecule. So the best example of triatomic molecule, or the simplest example of the triatomic molecule, is water molecule. So we'll try constructing the water molecule. So here the bonds are again, all the bonds in water molecule are single bond, and choose oxygen here and click on this portion. So it will automatically give you water molecule, because as soon as you click on this by selecting oxygen atom, so to satisfy the valency, so it automatically produces two hydrogen atoms, so which is our water molecule. Now you could click on this navigation tool to rotate or to view it from a different angle. You could also drag it from one portion to other, so like this. Okay, so this is your water molecule. Yeah, so you could also zoom in and zoom out using this navigation tool. Yeah, so this simple zoom in and zoom out can be done using the way we do on this on our mouse pad. Now you could use the measuring tool to get the distance between the hydrogen and get the distance between the hydrogen and the oxygen. Okay, to do that, click on the hydrogen atom and the oxygen atom. So oxygen atom is numbered as 2, and the distance between this hydrogen and this oxygen is 0.97 angstrom. Then when you click on the third atom, so which is hydrogen, so you'd able to see the angle between this OH bond, which is basically angle 123, and which is 109.5 degree. Now let's optimize this geometry using the same options, that universal force field and steps for update for start optimizations. Now you can see the angle got reduced to 104.5 degree, and the distance also 0.990 angstrom. Okay, so this is a triatomic molecule. So before construct anything complex, yeah, I just want to show a demonstration about this build options, what are available in the build options. So we are going to construct for halo benzene, which is basically a benzene molecule. All these hydrogen atoms are replaced by the halogen atom. But before doing that, let's use this build option, insert option. So what are available in this? So go into this fragment. So yeah, so but here we are going into any particular particular folder in this fragment, because later we are going to construct the same molecule by hand. Now in this fragment, when you go into this in aromatics, so there are several options available, sort of which yeah, out of which we could choose benzene and insert that. So this is your benzene molecule. So this is how benzene molecule. So benzene molecule looks like, and all these atoms, they're selected. So you could deselect them by using the select option. So there's the select none. So now you can see. So this is a benzene molecule. So I was talking about constructing a porhalobenzene. The next part is just to replace the hydrogen atoms with the fluorine atoms, with any halogen. So here we are choosing fluorine atom. So to do that, we have chosen the fluorine atom. So you just have to click on the atom you want to replace. So here these atoms are hydrogen atoms. uh, by clicking on those hydrogen atoms, so we are replacing hydrogens by fluorine. So this is a porhalobenzene. So where we have used the fragment of benzene, so which was already available in the build option. So we haven't constructed this molecule by hand, but we could do the same by hand. But the advantage of using this fragment is, like, I mean, it would reduce the time consumption. So let's construct the same molecule by hand. Okay, so first we have to do something like cyclohexane like molecule. So this is your carbon. Okay, so draw like this, because we have chosen every bond as a single bond, so we could drag like this. uh, then something like this. You always have to put your cursor on the center of the carbon atom, not any other atom, because that would produce something wrong. Then from this carbon to this, and this carbon to this. Now we have constructed something like cyclohexane. So don't worry about the bond lengths and bond angles in this molecule. So because this is not the optimized thing, and this is not also the end product which what we want. The next thing is to add double bond. So here in this drop down menu of this bond order, so select this double and add this bonds. So this is basically this adding step is so if you want to add a double bond between these two carbon atoms, just drag from one to other. Similarly, you could do to other pair of carbon atoms. Okay, so now this is something which looks like which is benzene like. The next step is replacing the hydrogen atoms with fluorine. So you could do that by clicking on that. Okay, just click. So now this is starting for halobenzene, or which is for fluorobenzene. So we could use the geometry optimization to optimize this. Okay, so now, yeah, now it got optimized. So stop the optimization step. So now you can see this is our for halobenzene or for fluorobenzene, which we have constructed by hand. But the same thing we also had done using this build option. So this build option has several fragments, several other fragments which you could use directly instead of constructing this by hand. Also, this large or gigantic molecules like DNA, RNA. So these also you could get from this build options. So in this way, one could construct any molecule. So I would encourage all the viewers to play with this. Thanks for watching this video.